In the previous video, we had studied about the calculations of mole concept. In this video, we are going to be talking about percentage composition. So, we know that percentage just means that how much amount of something is present in 100 times. Or like to put things in a better format, like suppose you have this consists of 100, so the percentage of water that could be filled in this beaker, suppose if fills up to 20, it means the 20% of the beaker is full, right? So that's, you would have learned about percentage in mathematics basically. So percentage composition is basically the number of grams of an element in 100 grams of a compound. So basically, we just mean that in 100 grams of a particular compound, what is the amount or number of grams of the element that is given by the percentage composition. So the general formula that you have for percentage composition is mass percentage of an element equals to the mass of the element or the constituent mass of the element or constituent in 1 mole of the compound divided by the molar mass of the compound. And this will be multiplied into 100 because it's a percentage. Usually the units of this will get cancelled with this, and so you will have it as gram per mole and gram per mole, both of them will get cancelled, and into 100 because you have the percentage. Now let's take for example water. Okay, in water, the molecular or the molar mass of water of H2O would be equal to 2. Here we're taking the mass of hydrogen as 1.008 plus 16.00. This will give us 18.016. And if you remember, when we'd spoken about the addition in significant figures, it was said that the number of significant or the decimal points which you have should be equal to the one which has the least number. If you have any doubts, do check it out. So based on that, you'll have to reduce it to 2 decimal points, and further, because we are removing a 6, this number will be changed to 2, so 18.02 grams. Now the mass of hydrogen in 1 mole would be equal to 1 mole of water, not hydrogen. 1 mole of water would be equal to 2 into 1.008 grams. This will give us 2.016 grams. Okay, now we are just multiplying the number of hydrogen atoms in 1 mole and converting into grams, because 1 mole of a particular substance will be equal to its gram atomic mass. If you do not know this, do check out the video on molecular mass and the mole concept. So the mass of hydrogen in 1 mole of water is 2.016. So the percentage mass of hydrogen would be mass of that element or constituent in 1 mole, we've gotten that. So that's 2.016 grams over 18.012, 18.02 grams. So after you simplify, the value is approximately 11.19%. Similarly, mass of oxygen in 1 mole of water would be equal to 16.00 because you have only one atom of oxygen in water. So the mass percent of oxygen would be equal to 16.00 divided by 18.02 grams. That's equal to 88.79%. So in water, the molecular, we are first calculating the molecular mass. Okay, and then we are calculating the mass of the individual elements in 1 mole, which is basically the atomic mass into the number of atoms which is present, right? So that will give us the mass of hydrogen in 1 mole of water, and then we're calculating it by the formula of mass of the element in the constituent in 1 mole or constituent in 1 mole of the compound divided by the molar mass of the compound, and all of this will be multiplied, oh I am so sorry, into 100. Into 100. So the calculation is right. I'm so sorry. I should have written into 100. So only if you multiply it with 100, you get it in terms of percentages. Okay. Now the other example we are going to be considering is ethanol. So ethanol's molecular formula is CH3CH2OH. Okay. So this is the molecular formula of ethanol, and we need to calculate the percentage mass of what? Carbon, hydrogen and oxygen in ethanol. First of all, its molecular formula is equals to C2 H3 plus 2 plus 1. So 6O. So C2H6O is being taken. Now the molecular or molar mass of ethanol would be equal to 2 into 12.01 plus 6 into 1.008 plus 16.00. And now this, after simplifying all of this, or first we multiply 24.02 plus 6.048 plus 16.00 grams, and this gives us 46.068 grams. Now only after you finish the last step should you actually consider the number of significant figures. Now here, after the decimal point, you have only 2 digits, right? That's the least number. This has 3 and this also has 2, which means our answer should have only 2 digits. And here your 8 is present, which means this has to be added by 1. So 46.07 grams. For if you have not, do check out the video on significant figures. That gives you a detailed understanding as to how to do all of this and how to round off the values. So now we have to calculate the mass percent of carbon. So mass percent of carbon would be equal to what? The mass of the element or the constituent in 1 mole, which is nothing but 2 atoms, right? So 2 into 12.01 divided by 46.07 grams into 100, and this gives us 52.138%, but we will be rounding it off to 2 digits to give us 52.14%. Okay, so all we have to do, remember, all we're doing is we're taking the number of or the atomic mass into the number of atoms which are present. That's it. So here again, mass percentage of hydrogen. Okay, so the mass percentage of hydrogen will give us the value. What you need to take 6 into 1.008 grams divided by 46.07 grams, this whole into 100, and when you simplify that you get 13.127%, and since we are getting it to 2 decimal points, it will be rounded off to 13.13%. Similarly, mass percentage of oxygen would be 16.00 grams divided by 46.07 grams into 100, and this gives us 34.729%, and we are rounding it off, so you get 34.73%. So all we are saying is, in a percentage composition, we are considering how much is the mass of element in 100 grams of that compound. That's it. Okay, so the percentage, so if our compound, if we had 100 grams of that compound, 52.14 grams would be for carbon, 34.73 would be oxygen, and 13.13 grams would be of hydrogen. So basically, percentage composition is giving us how much amount of that particular substance is there, right? We had also studied about percentage composition in one of the laws of chemical combination. Based on that only, we were able to find out, we had talked about copper carbonate, right? So percentage composition will just give us the information also about the purity of a particular compound. Like suppose if something is not pure, right, the percentage composition would not be of that particular element in that compound would not be the right amount. Okay, so that's about it. So the next video we will be studying about the molecular formula and the empirical formula. Do check.